There is one nutrient that your liver cannot function without, your brain uses to make its primary memory neurotransmitter, and 90% of Americans don't get enough of. It's not a supplement. It's classified as an essential nutrient. And the reason most people have never heard of it is that it was only designated as officially essential by the Institute of Medicine in 1998. The substance is choline, and its research record is more impressive than almost anyone realizes. Choline is the precursor to acetylcholine, the neurotransmitter most directly involved in memory formation, muscle activation, and attention. It's also required to synthesize phosphatidylcholine, the primary structural phospholipid of every cell membrane in your body. And in the liver, it's essential for VLDL particle assembly, the mechanism your liver uses to export fat. Without adequate choline, fat accumulates in the liver. That's the mechanism behind choline deficiency-induced fatty liver disease. The choline research comes from both epidemiological studies and controlled depletion trials, a uniquely powerful combination. The Framingham Heart Study provided large-scale data on choline intake and cognitive outcomes. Controlled choline depletion trials in Fischer and Zeisel's work documented the consequences of deficiency at the organ level. And lipid research established the liver transport mechanism. Together, they make a compelling case for choline as a priority nutrient. The most consequential misconception about choline is that it's only relevant for pregnant women. While the fetal need for choline is critical, it's essential for brain development and dramatically reduces neural tube defect risk, the adult need is just as real. The liver requires choline continuously for fat transport. The brain uses acetylcholine for every voluntary movement and every declarative memory. The idea that choline is just a pregnancy nutrient has left most adults chronically deficient. Controlled choline depletion trials, where participants were given choline-free diets under clinical supervision, produced disturbing results rapidly. Within 3 to 4 weeks of choline depletion, liver enzymes rose dramatically in the majority of participants, indicating liver cell damage. Muscle weakness and fatigue appeared within weeks. When choline was restored, these markers normalized. This established definitively that choline is not optional. It is a required input for normal liver and muscle function. Choline's role in fatty liver disease is mechanistically straightforward and clinically important. The liver packages and exports fat in the form of VLDL particles, a process that requires phosphatidylcholine as the particle's outer coat. Without adequate choline, VLDL assembly is impaired, fat cannot be exported, and it accumulates in the liver. This is the exact mechanism of non-alcoholic fatty liver disease in choline-deficient individuals, and it's reversible with choline repletion. The Framingham Heart Study analysis published in the American Journal of Clinical Nutrition examined choline intake in over 1,200 adults and correlated it with cognitive performance. Adults in the highest choline intake quartile performed significantly better on verbal memory and visual memory tests compared to the lowest quartile. Importantly, higher dietary choline was also associated with lower white matter hyperintensity volume, an MRI marker of brain aging, suggesting a neuroprotective effect beyond acute cognitive function. The acetylcholine connection explains why choline deficiency manifests as cognitive decline. Acetylcholine is the primary neurotransmitter involved in the hippocampus, your brain's memory consolidation center. Alzheimer's disease is characterized by a severe loss of cholinergic neurons. While choline doesn't cure Alzheimer's, adequate lifetime choline intake appears to support cholinergic system health and reduce risk. Studies show dietary choline intake in the adequate range is associated with measurably better memory performance across the adult lifespan. The food sources highest in choline are specific and concentrated. Eggs are among the best. One large egg provides 147 milligrams of choline, about 27% of the daily adequate intake. Beef liver is the highest single food source. Salmon, beef, and soybeans are also excellent sources. The critical problem is that many people following plant-based or low-egg diets have no reliable high-choline food in their regular rotation, making this deficiency especially prevalent in specific dietary patterns. Choline supplement forms have different tissue distribution profiles, similar to magnesium. Alpha-GPC and CDP choline are the best documented forms for cognitive applications. Both cross the blood-brain barrier efficiently and are used in clinical trials for memory and cognitive performance. Phosphatidylcholine is the best form for liver support and general systemic use. Choline bitartrate is common and less expensive but has lower bioavailability for brain applications. The choline optimization framework starts with diet, specifically ensuring adequate daily intake of high choline foods. For most people, 2 to 3 eggs per day covers a significant portion of the 500 mg adequate intake for adults. Organ meets weekly add concentrated choline. For those with cognitive goals or who have limited food-based sources, alpha-GPC supplementation at 300 to 600 mg is the best validated approach for brain-specific benefits. Choline's timeline for effects depends heavily on the starting point and the goal. Liver enzyme normalization in choline-deficient individuals appears within 2 to 4 weeks of adequate intake. Cognitive improvements, particularly memory consolidation, tend to be gradual over 6 to 12 weeks as brain cholinergic tone improves. Acute cognitive effects from alpha-GPC supplementation can appear within hours in people whose cholinergic system is undersupported. Here is the practical daily choline protocol. Aim for 2 to 3 whole eggs per day. The yolk contains all the choline, egg whites have none. Add a high choline protein source at each meal: salmon, chicken liver, beef, or edamame. If you follow a plant-based diet, choline is one of the most important nutrients to supplement, as plant foods generally provide less than half the choline density of animal sources. The specific form of choline supplementation should be matched to your primary goal. If cognitive performance and memory are the priority, alpha-GPC has the strongest clinical trial evidence for brain-specific effects. If you're managing fatty liver disease or liver health concerns, phosphatidylcholine is the most physiologically appropriate form. If you want a general choline supplement that covers both bases adequately at reasonable cost, CDP choline is a well-studied middle option. Choline is the overlooked essential nutrient that simultaneously supports two of the most critical systems in your body, the liver and the brain. Its role in fatty liver prevention, memory neurotransmitter synthesis, and cell membrane integrity makes it foundational. 90% of Americans don't get enough. The fix is straightforward. Eggs, organ meats, and fish are the dietary answer. Alpha-GPC is the supplement answer for cognitive goals. The biology is clear. The practice just needs to follow. 1 nutrient. 2 critical organs. 90% of people deficient. Choline doesn't get the attention it deserves, but the research makes the case clearly. 2 eggs a day and a serving of fish keeps your liver exporting fat and your memory neurotransmitters running at full capacity. Research shows this pattern is more consistent across populations than previously understood. Studies find these effects are measurable and reproducible across independent research groups.